Hello everyone, welcome to Algebra 2 Notes 1.4, Algebraic and Verbal Expressions. This should be a pretty quick section of notes, 10 minutes or less, so no worries there. We'll be able to fly straight through it. So let's jump right in. The first thing is just an official definition of expressions. So expressions are used in algebra to express some equation or formula. Verbal expressions use words, and algebraic expressions use numbers and symbols. Pretty straightforward. So a basic example of a verbal expression for our example here would be 4 less than a number is 4. And that can be kind of confusing when you just hear it. So we're just going to practice writing some of these out. So 4 less than. So I like to kind of break these into independent little boxes. So we've got 4 less than a number, got right here, is 4. So a lot of these pretty straightforward basic words really contain some type of algebraic symbol. So is pretty commonly just an equals. 4, of course, we would know as 4. So the phrase is 4 altogether would just be equals 4. And you can section these out and write these really in whatever order you want. 4 less than, so negative 4, a number is 4. I like to write these backwards sometimes too. So once I understand that we're looking at a negative 4 here, and some number, we'll just use n as an example here, we know that these are going to be combined, and the way that we're combining them is just 4 less than, so subtraction. So really, this is just 4 less than a number. So n minus 4 equals 4. Once we have all of the pieces, it's just lining them up like that. You can solve this. It's not a necessary step of this, but we would get n equals 8. So really, this is just telling us that a number is 8. The variable here, in this case, is n. Over to the next one, the sum of 7 and 2 times a number. This can be kind of confusing. When we're talking about the sum of something, we're automatically going to consider it something within brackets. So the sum of 7 and 2 times a number. So sum of 7 and 2 would just be 7 plus 2, but again, in brackets, times a number, and we can use n. We can really use anything. We could use x, just a number, a variable. It's not saying a number n or a number x. Then we would have the variable defined for us already, but that's not necessarily the case here. And that would be fine. You can rewrite this more common form with the variable out front, so plus 2, and of course we could solve it by either adding these or distributing, but it's just going to simplify out to 9x. But that's not a necessary step here. The next section would be algebraic to verbal. There's lots of different ways that you could define this phrase using language. I like to attack it in a somewhat specific way. I actually work from right to left, and you'll see why here in just a moment. So n squared minus, so a number squared. So that's defining this piece right here. And that subtraction less than 4. I don't know what I'm doing right here. Let me rewrite that. Less than 4. And that's exactly it. Then I like to take my way back through this phrase and see if I was not specific enough or explained anything incorrectly. So a number there squared less than 4. Less than 4. So we're starting with 4 and we're taking away a number squared from it. Perfect. That looks like it works to me. And for this next one, so this one has an equal sign. Let's see, x minus 15 equals 21. So again, I'll take this phrase first and then work from right to left. So 15 less than a number is, and that's that equals sign, 21. And that's it. Let's jump down to the next section here. So these are all properties of equality. When we're dancing around some type of equal sign like this, these are different properties that we're going to be looking at. So all real numbers, just as this last 1.3 was talking about the properties of them, properties of equality all assign themselves to real numbers as well. So let's see. There's I think dozens of properties of equality, but we're going to focus on the most common four, just the reflex property, the symmetric property, the transitive property, and the substitution property. And these are all properties that I would have expected most of you guys have used in Algebra 1. You may have not been taught the specific word for them or the specific title of these properties, but I'm sure that you've used them. So the reflex property is pretty straightforward. If A equals A, then you can substitute it around. So a good example is, it doesn't matter how gross this is, it doesn't matter what x equals or what y equals, it is going to equal this because they're the same. It seems pretty silly to consider something like this, but I mean that's the reflex property for you. Pretty straightforward. So reflex, I like to write in a hint of just equals. It's the most basic property of equality. The symmetric property states that if some number equals another number, then that other number equals the first number. We're getting kind of weirdly specific here, but it's just like flipping things around. So 11 equals 3x plus 2, then 3x plus 2 equals 11. And that's the symmetric property. So I like to think of this as flipped, or ABA, AB, BA. That's just because A equals B, then B equals A, and ABA was that wonderful group from quite a while ago. The next would be the transitive property. And this is just kind of taking one extra step from the symmetric property. So if A equals B, and, I'm not going to do a plus sign, that might confuse a few folks, and B equals C, then we can conclude that because A equals B and B equals C, that A equals C. Just kind of taking out that middle step right there. And that happens a lot more in higher level math because it's easier to manipulate specific types of real numbers than it is to manipulate one large expression. So, and you can use that to solve systems of equations. So if we had 5x equals 10 and 2x plus 6 equals 10, then 5x equals 2x plus 6. So I just write in transform. So, or transit, going from one spot to another, because you have to go from A to B to get to C. It's a necessary step there. The next would be substitution, and this is something that I know you guys already have used plenty of times. If A equals B, then A can replace B and B can replace A. And you do this in phrases. If someone says, okay, x equals 3 and y equals 4, what does x plus y equal? Well, that's just as simple as substituting out. So we know x equals 3. So instead of writing x, we can write 3, and we know y equals 4. So we can just write 4, and that'd be 7. So it's just substitute in or swapping out. So I just write in substitution, or swapping. Really, whatever phrase here works for you. There's no right answer to write in here. It's whatever is going to make the most sense to you. And then over to some practice. So we're just going to, this is really practice for 1.3 and 1.4, but let's distribute for the first time. So the easiest way is to take the smaller number outside of the parentheses and distribute them in. So for this one, we would take the square root of 13 and multiply it by the 4 first. So we get 4 square root of 13 plus x square root 13. That's as simple as that. For this, we'll take the 3 and distribute it to the 2x and the 2. So we would get 6x plus 6. Easy enough. And even if we have multiple variables in a parenthesis grouping like this, we can distribute it to both of those variables. So this would just turn into 5a plus 5b. Next, here on the bottom, we're just going to simplify these expressions. And these can take multiple steps, but if you go through the steps nice and slow, you shouldn't encounter any errors here. So let's distribute this 4 first into the 2c and the 3d. So we have 4c plus 6d plus, let's see, 6 and 2 is 12d minus 6 and 7 would give us 42c. And now we just need to combine like terms. So the two d's here would go together, so we would get 18d, and the positive 4c and the negative 42c would turn into negative 38c. That'd be plus 18d. So that's what we're looking for this type of problem. For number 3, we can distribute fractions. So we would just really multiply this 14 by 1/2, which would give us 7, and this 2 by 1/2, which would just give us 1x. And if it's just 1, we don't need to write it if it's in front of a variable. Now this is plus negative 3/4, and then this quantity. So we'll distribute the negative 3/4 into both of these numbers. So negative 3/4 of 4 would be negative 3, and negative 3/4 of 16x would give us minus 12x. And then we're just going to combine like terms. So the 7 and negative 3 would add together to give us 4, and the x and the negative 12x would add together to give us 11x. This next one has two sets of brackets. We have a small set of brackets here and a larger set here. We can distribute this 3 first if we want to, but it can get a little bit confusing. This 2x would turn into 6x, and this 3 would turn into 9, but we'd still have to distribute the 9 across those two. I think it's a little bit simpler if you just start from the inside and work your way out. So we'll start there. We'll distribute this 3 in to this x plus 1, so you would get 3 within brackets, that's 2x plus 3x plus 3. We can combine like terms right now, so it would be 3, 5x plus 3. And then we can distribute that 3. We would get 15x plus 9. And that's what we're looking for there. If you have any questions, please see me or Miss Kavanaugh in class, or you can send us either emails. We'll see you there.